Hi, subscribers and viewers. Welcome back to my channel, Cambridge Muneeb. So, in today's video, we shall now start with the solution of the 0620 IGCSE Chemistry, Paper 2, Variant 3. Okay, and this is extended paper. So, let's start with the first question. The question states, sodium chloride is a liquid at 900 degrees centigrade. Which row describes the arrangement and the motion of the particles in solution chloride at 900 degrees centigrade? And then we are provided with the table. In this table, we have to match the particles arrangement and its motion with the physical state of the sodium chloride at 900 degrees centigrade. So we can see that at 900 degrees centigrade, the particles are in the liquid state, which means we should know what their arrangement is like. The arrangement of the particles in the liquid form is always a random form. So we will select the random form of the arrangement of particles. And then secondly, we should also know that the motion of the particles when they are in the liquid form, they move randomly. They are always in the motion, so they move randomly. They do not vibrate at a fixed position because this property belongs to the solid form of the particles. That is not the case here. Instead it is a liquid form, so that's why the right option becomes the D option. The right option is the D. Now moving ahead, question number 2. The question number 2 states hydrogen chloride HCl gas reacts with ammonia to form ammonium chloride. The plate is set up here. After a few minutes, a white cloud of sodium solids ammonium chloride forms where the two gases meet. Now we have this diagram and we have this solid ammonium chloride formation over at this point in this tube. The experiment is repeated using hydrogen bromide HBr in place of the hydrogen chloride. How far along the tube does the white cloud of sodium solid ammonium bromide form? Okay, so for this question we need to compare these two diagrams, and we are also provided with another reactant instead of the HCl for the formation of the solid compound. In the previous case, the solid compound which was produced was the ammonium chloride. Ammonium chloride has the formula of NH4Cl. In the second case, the compound which was formed was ammonium bromide, which has the formula of NH4Br. And how is it produced? It is the same case, just like the previous case. HCl plus NH3 produces NH4Cl, whereas in the second case ammonium was still the same, but the other compound was HBr instead of the HCl, and this produces the NH4Br. Now they are asking at which position this ammonium bromide will be produced. We can see that in the first experiment number 1, in experiment number 1, the NH4Cl was produced at this point, and if we match this diagram with the other one, it is consistent with the point number B over here, which means in the first case the compound NH4Cl was produced at point number B, but when we have this NH4Br, then there is a difference of the mass of the Cl versus bromine. We know that ammonia gas is being moved from here and HCl gas is moving from left side. The same is the case for the second diagram, where ammonia gas is moving from right to left and the hydrogen bromide gas is moving from left to right. But now there is a difference in the masses. HCl mass of the HCl versus mass of the HBr. Now considering the periodic table, you will find out the masses of both these elements. Now we can find the masses from the periodic table. Chlorine has a mass of 35.5 here. 35.5, whereas the mass of the bromine element is 80, which means it is clearly seen that chlorine is lighter in mass as compared to bromine, or in other words, bromine is heavier than chlorine. So because of this reason, the compound, because of this, the movement of the hydrogen bromide will also be slower as compared to the hydrogen chloride gas. So HBr will move slower than HBr, that is clearly seen because of the mass, because mass is inversely proportional to the speed of the movement. So because of this reason, we will say that HBr will move slower, and the time which is taken for the time which is recorded for the movement of both the ammonia gas and hydrogen bromide is the same, but in the same time HBr will move less. So the only point which we can see in the second experiment number 2, the only point which shows that HBr will have moved less than experiment number 1 is only the A case, which means the HBr would have moved up to point number A, and that is where the ammonia gas would have approached for the formation of the ammonium bromide. So ammonium bromide would have produced at this point. I hope the students would got the answer, would got the concept, and they are clarified with this question. So A option is the right one. Now the next question, number 3, it states substances P and Q both conduct electricity. P is a mixture of 2 different types of atoms, so and Q is made of only one type of atom. Then we have to match these information with the given provided table. It says that substances P and Q both conduct electricity. So in this case, P can definitely be an alloy as well as a compound, but we are not sure which one. And Q states that Q can also conduct electricity and a compound, that is again correct, but we still are not familiar with which substances are these one. The second statement says that P is a mixture of the 2 different types of the atoms. 2 different types of the atom means 2 different elements. It means 2 different elements are there, not just one type of the element, but 2 different types of the elements. And Q is made of only one type of the element, so there is just one element here. They are not 2 different elements, instead there is just one element here. It means that we can now match this information, we can match this statement with the provided information in the table. Okay, when it says that P is a mixture of 2 different types of the atoms, then, or in other words 2 different types of the elements, then it is clear that it can only be alloy. Why? Because mixture means it is not chemically bonded. It is just addition of 2 compounds, not chemically bonded. So that's why alloy is the only case here where there is a mixture of 2 or more elements. Alloy means having 2 or more metals, or metals plus any other non-metal. They can be both cases here. So I can show you in the notes of the book. This is the book. In this book you can see that what is alloy. Alloy over here is these are the examples: brass, bronze, and mild steel, stainless steel. Here we can see their composition in the next column, that brass is composed of copper and zinc. These both are metals. Bronze is again made up of two metals, but mild steel is made up of iron, which is a metal, and another element which is not a metal. Iron is a metal, but carbon is a non-metal. Or so that's why we can say that alloy is just a mixture. Alloy is a mixture of two or more than two elements. Here is the definition of the alloys. Mixtures of elements, usually metals, designed to have the properties useful for a particular purpose. Example, salt are an alloy of tin and lead has a low melting point. So that's how we can identify that the given compound, here we have alloy, and the column of Q we need to find which one is the right one, element or compound, and it says that it is made up of only one type of the atom, which means it is made up of only one element. So because of this we cannot say it is a compound, instead we will only say it is an element. Q is an element, not a compound. And yes, within the alloy we have or not just alloy, instead we will say just that the statement Q means an element which can conduct electricity. So because of this the right option becomes A. A is the right option. Next question number 4. An atom of an element R contains 15 protons, 16 neutrons and 15 electrons. What is R? So as you know that to find out the identity of an element in the periodic table, you should always know one unique number of the element. That unique number which is only associated with one particular element. No two elements can have that unique number, and that unique number is the atomic number. Atomic number is always different for every element, and atomic number represents the number of protons in the nucleus of an atom. So for this element R, which is not the right symbol, instead it is an unknown element. For this element the number of protons are 15, and when you check this in the periodic table you find that atomic number 15 belongs to element P, phosphorus. So atomic number 15 belongs to phosphorus. So that's how we know that this is the phosphorus element here, and the right option becomes B. B is the right option. The other information is just to make you confused. It is just making confused for the element, because for those students who do not know that the atomic number is the actual identity, they will get confused by looking at these values, neutrons and the electrons. So next question is number 5. Which molecule contains a double covalent bond between two atoms of the same element? Okay, so in this question we need to construct the formulas of these elements, only then we can know the right answer. For carbon dioxide I will just write a simple structure. Carbon dioxide is shown in this form. This is the formula of the right formula of carbon dioxide is oxygen double bonded with carbon double bonded with oxygen. That's the right formula of the carbon dioxide. So in this structure we see that there is no double covalent bond between two atoms of the same element. This is the double bond between carbon and oxygen, and same is the case here. It is a double covalent bond between carbon and oxygen, and they are two different elements. These are not the same element, so this is not the right answer. Now check for the ethanol. This is for compound A, and then if I draw structure for compound B, I need some space so that all the structures are shown in this provided area. Ethanol is shown like this. Carbon is bonded with hydrogens here, and with another carbon which is bonded with another hydrogen above and below, and with oxygen which is bonded with the hydrogen. You can see that within this ethanol there is not a single covalent, there is not a double covalent bond anywhere, so that's not a right answer. Same the case for A. If I draw the structure for nitrogen C, nitrogen is basically considered as N2. So for N2 we should know that nitrogen is triply covalent bonded with another nitrogen atom here, and there is a lone pair on the either side of the nitrogen. So we see that although there are two atoms of the same element here, the information is correct here, but it is not a double covalent bond, instead it is a triple covalent bond. So D option becomes the wrong answer. Sorry, my mistake, it should be written D. Now we are left with only C option. For the C option, the structure is like this: carbon is bonded doubly with another carbon atom, and there are two hydrogen atoms on each carbon atom. This is the structure of the ethene. So we see that a double covalent bond is between the two carbon atoms, and that's why the right option becomes the C over here. Now the question number 6. Silicon oxide is a covalently bonded compound. Which statements are correct? So here we need to have the clear picture of this silicon 4 oxide, which is written as SiO2, and it is a macromolecule, covalent macromolecule. The four statements are: silicon atoms form 4 single bonds in a silicon 4 oxide. We have to check if it is correct or wrong from the diagram. Then we have oxygen forms 2 double bonds in the silicon 4 oxide. Silicon oxide has a high melting point, and silicon oxide contains 1 silicon atom and 4 oxygen atoms. Now to have this clear picture, we should have some idea from the theory. So I'm going to show you my all levels notes, my IGCSE chemistry notes. From here you can find the real picture of the silicon oxide. In this table you can see that this is the three-dimensional structure of the silicon oxide. You can see that silicon is making single bonds with the oxygen. These are this one is silicon and this one is oxygen. So you can see that they are all single covalent bonds between the silicon and the oxygen atoms, and there is no double covalent bond between them. That is one point. And the other one is that each silicon is making bonds with 4 oxygen atoms. I have to change the color so that you can clearly see the silicon making bonds with 4 oxygen atoms here, and each oxygen atom is making bonds with 2 silicon atoms here. This oxygen is bonded with this silicon as well as with this silicon atom, or for this red you can see that this is one silicon and this is the right silicon or the second silicon. So every oxygen atom is bonded with 2 silicon, and every silicon is bonded with the 4 oxygen atoms. Because of this, we can say that the ratio between the oxygen and the silicon comes out like this one. It says clearly here. Then when we have this type of the ratio, when they are let's see, 4 silicon atoms bonded with 2 oxygen. My mistake. For every 2 silicon atoms, there is a ratio of 4 oxygen atoms. So the simple ratio becomes SI ratio 2 oxygen atoms, or in other words 1:2. That's why we always write it as SiO2, because for every 2 silicon atoms there are 4 oxygen atoms. So that's why the ratio is 1:2, or the formula is SiO2. And another property of the silicon oxide is that it has a very high melting and boiling point. This is a property under the silicon oxide that they have high melting and boiling points. So considering all these points, we can check from this given points, multiple points, that silicon atoms form 4 single bonds in single silicon oxide. That is correct. Number 2, oxygen forms 2 double bonds in silicon oxide. That is wrong. They form 2 single bonds, not double bonds. And 3, silicon oxide has a high melting point. That is correct. And for silicon oxide contains 1 silicon atom and 4 oxygen atoms. Now this is incorrect, because when we check the ratio, then we see that for every one single silicon atom there are 2 oxygen atoms. That is the simplest ratio. We are not considering that in the overall silicon oxide there is the bonding of 1 silicon with 4 oxygen atoms. Instead we have to check this in the simplest form of the silicon oxide formula, where there is a ratio of 1:2. SI ratio of oxygen is 1:2. So there is 1 silicon atom for 2 oxygen atoms. That's why this option 4 becomes incorrect. Because of this, we can clearly see that the right option becomes B. B is the right option. Now question number 7. The equation for the reaction of iron 3 oxide with carbon monoxide is shown. We have this equation, and then we are asked what is the percentage yield of iron when this amount of carbon monoxide reacts completely with iron 3 oxide to form this amount of the iron. Okay, so for this question we are provided with the value of the 8.96 gram of the iron, and we need to find the percentage yield. You should know that percentage yield is calculated by percentage. The percentage yield is calculated by the formula of actual yield, or you can also say as experimental yield divided by the theoretical yield, or calculated yield as well. Sometimes it also said calculated. Okay, now into times 100. Now this value, which is given as the form of 8.96 gram, will be considered as the actual yield or the experimental yield, but we do not know the theoretical yield. So for this purpose we need to find the value of the theoretical yield, and it also say that 16.8 gram of carbon monoxide reacts. So we say that 16.8 gram reacts with the iron oxide, and we need to find how much theoretical yield of this iron will be produced. So that's what we have to find in this question. Okay, now how can we find this? Here we are given the mass of the carbon monoxide. So this mass of the carbon monoxide, we can draw this equation backward. For example, here we need to find how much mass of the iron is produced. Mass of Fe is unknown. For this purpose we need to use this formula, where number of moles is calculated by the mass over relative atomic mass, and this M becomes N times AR. We can use this AR from the periodic table, but we do not know the value of the number of moles of iron. So to find the number of moles of the iron, we need to have the ratio method here, the number of moles of iron versus the number of moles of the carbon monoxide. So now for this purpose we need to find the number of moles of carbon monoxide, and to find this we can find the number of moles of carbon by the formula just like the previous one, where mass of the carbon monoxide divided by its MR value is used. The carbon monoxide mass is already given as 16.8, and we need to find the number of moles where MR can easily be calculated. So that's how we can move backward to find the mass of the iron. It is always, that's the always I give instruction to my students. I always give this strategy to my students when they have to find the right answer. Always go backward. Okay, so starting from the last point here, that is find the number of moles of carbon monoxide. So the number of moles of carbon monoxide will become its mass, which is 16.8 gram over here, divided by its relative molecular mass. The relative molecular mass of carbon monoxide becomes 12 plus 16, which is 28. So I will divide this by 28. The answer becomes 0.6 mole. Now we have calculated the mole of the carbon monoxide. We can now use the ratio method, where moles of the iron is found using the moles of the carbon monoxide. For this purpose we need stoichiometry moles as well. Here the moles of the carbon monoxide calculated is 0.6 mole and iron is unknown. And the second step, we need to use the stoichiometry moles. Here you can see that the mole of the carbon monoxide is 3 and the mole of the iron is 2. So we'll put these values here: 2 moles for iron, stoichiometric moles of the iron 2, and stoichiometric moles for carbon monoxide are 3. Now in the next step we do the cross multiplication. So this x which is to be found, x will become 2 into 0.6 divided by 3. Now this value will be 0.4. Okay, we have calculated the moles of the iron, that these are the moles of the iron. Now in the next step we have to find the percentage yield. So for percentage yield we got the actual yield, which is we have still find the mass. It is still not completed yet. We have got the moles of the iron, but we need to find the mass of the iron from it. So using this formula which I used here, mass is the mole times AR. So it will become mass of the iron will become the 0.4, which is the mole of the iron, times its relative atomic mass. From the periodic table you can see its relative atomic mass, which is 56. Now 56 times 0.4, it becomes 22.4. Now this is the actual yield in gram, actual yield. Now the last step which we need to find here is the percentage yield. So percentage yield will become actual yield divided by theoretical yield. So I'm just putting the values here. Actual yield is now the 8.96 gram according to the statement, and the theoretical yield becomes 22.4 times 100. The answer comes out to be, from the calculator, is 40%, and that's why the right option becomes B. Now next question is question number 8. Now for question number 8, I need to remove some of the working from the previous question to make some space here. So question number 8 states that what is the volume of 14.5 gram of gaseous butane C4H10 at room temperature and pressure. Okay, so for this question we need to do a working again. You are provided with the mass of the butane, which is C4H10, but you are supposed to find the volume, which means that this mass must be converted into the moles, and then from the moles relationship we can find the volume. We can use two formulas here and also equate them here. We know that moles is equal to mass over mR, and also we know that moles in terms of the volume is volume of the gas divided by molar volume, where the molar volume at room temperature and pressure is equivalent to 24 dm cube. which means that we can use these two formulas to get a one single formula, that is mass over mr is equivalent to volume over molar volume, and we need to find the volume here. That's what the question is asking. We have to find the volume. So to find the volume, we will rearrange this equation to get the right equation. Volume is equivalent to mass over mr times molar volume. Now to put the values here, mass of the gas is already mentioned, it is 14.5 prime. Now the molar mass of the butane, mr of the C4H10 is equivalent to 12 times 4 plus 10, it will give you 58. So we will use 58 over here, and the molar volume, as I mentioned previously, that it is equivalent to 24 dm cube. So I'll put 24 over here. Now use the calculator to find the values. You will get the answer of 6. Now this 6 is it cm cube or dm cube? We can get this answer from the units we have used here for the molar volume. The used unit were dm cube, so that's why we will write 6 dm cube. So the right option becomes the D. The right answer is D. Now the next question is, aqueous copper 2 sulfate is electrolyzed using copper electrodes. We have this diagram here. Which statement describes what happens during the electrolysis? Okay, so we have to check the right option from these 4 given options. Number A, copper atoms gain electrons at the cathode and copper 2 ions lose electrons at the anode. Okay, we know that during the electrolysis, when we are given 2 electrodes of the same composition as copper, we know that at the cathode, which is negatively charged cathode, at cathode the positive cations are attracted, whereas on the other hand, on the copper anode, the positively charged cations are produced. I can show you in the form diagram from the resource books. Okay, so in this diagram from the book, you can see that it is the electrolysis of copper sulfate, and then you can see that at the anode the copper ions are being produced. The copper 2 plus ions, cations, are produced at the anode over here, and on the other hand, at copper cathode the copper ions are being attracted. So you can see that the formation of the copper ions is at the anode, formation is at anode, and the attraction is at the cathode attraction, which means we can say that cations or copper ions are attracted towards the cathode. So looking at the you can see one picture from here and another one from the other book. In this book you can again see that this is an anode. On this anode copper ions are being produced, whereas on the cathode the copper ions are being attracted. This is some sort of the impurities from the copper rod, and then when it moves towards the cathode the copper ions are being deposited. Now we have to go back to the question. It says that copper atoms gain electrons at the cathode and copper ions lose electron at the anode. It is clearly incorrect, because at the cathode the copper ions gain the electrons, not the atoms, and at the copper at the anode the copper ions gain the electrons. They gain the electrons at the anode instead of losing the electrons. It should be gain of electrons, so that's why this option becomes incorrect. So this is an incorrect option. Then number B says electrons move with the external circuit from the positive electrode to the negative electrode. So for this purpose we need to look at the picture again. Here is a picture of the movement of the electrons from the external circuit. This is the external circuit which is connected through the battery or power supply, and you can see that electrons are moving from the positive side to the negative side, from the positive electrode to the negative electrode, or you can say from the anode to the cathode. So looking back into the question, we can see that it says electron move in the external circuit from positive electrode, which is the anode, to the negative electrode, which is the cathode. So that is a correct statement. What about C? Copper ions move through the electrode from the cathode to the anode. So that was incorrect. When we saw this in the picture, that the cations were moving from the anode to the cathode. Movement is from the movement of the ions in the electrolyte is from anode to the cathode, whereas it says from cathode to the anode, which is incorrect. It should be from anode to the cathode. So this is incorrect. The D says copper is formed at the cathode and oxygen is formed at the anode. Now for this purpose we should know that the compound in the electrolyte is copper 2 sulfate, which means it is containing the Cu plus and SO4 2 minus from the SO4 minus 2 from the copper sulfate, as well as the aqueous means it contains the H2O, so it should also contain H plus and hydroxide ions. All these 4 ions are present in this electrolytic cell. But what is happening at the cathode and anode? At the cathode, which is the negative charge, this contains the positive ions of the copper, because at anode the electrode is made up of copper, so it means the copper atoms are being oxidized into the copper ions along with the electrons, and then these copper ions then move towards the cathode, where the copper ions are getting electrons and they are being reduced back to the copper atoms. Just like in this diagram, you can see that the 2 electrodes are made up of copper and the solution contains the copper sulfate, but here the ions are of only copper ions, because at anode the electrode is made of copper, so they are oxidized into copper ions and then they are moving towards the cathode to get reduced. So in this case the option D states that copper is formed at the cathode. That is correct, copper is formed at the cathode, but oxygen is formed at anode. That is incorrect, because at anode copper plus 2 ions are being formed at the anode, not the oxygen. This could only be happening when we would be using graphite as the anode, which is not the case here. So that's why D becomes wrong option. The only right option is B. Now the next question is, electrolysis is carried out on concentrated aqueous bromide using inert electrodes. Which products are formed at the anode and the cathode? Now in this question, the electrodes used are the inert, which means they can be graphite or platinum electrodes. Now using these electrodes, the compound which we are taking is a concentrated aqueous potassium bromide. It is a concentrated potassium bromide in the aqueous form. So here the products to be formed at the anode and cathode should be associated with the concentration. We know that they can be either concentrated or it can be diluted. For the concentrated compound, the amount of the ionic compound is more. Ionic compound amount is more as compared to the H2O, in which the ionic compound has been dissolved, whereas in case of the diluted, the H2O amount is more than the ionic compound. So we can also see this in the reference book, that it says it is important to understand that different products are formed when concentrated sodium chloride solution is electrolyzed rather than the molten sodium chloride. They are taking the example of the sodium chloride instead of the potassium bromide. So we can also say the same thing for the potassium bromide, when it is in the concentrated or it is in the molten form. Molten means the diluted, because in diluted or molten, here we can say diluted instead of the concentrated, because in the diluted form the amount of the water is more, H2O amount is more. Now the second factor which we need to find is the cations which are present in this aqueous form. Here in case of cations, we have the hydrogen ions versus the potassium ions. So which one will be discharged at the cathode? It depends on the reactivity order. So to see the reactivity, I will go back to the book again. So in this book, you can see that the potassium ion is at a top position versus the hydrogen ions, which is at a very low position as compared to potassium ion. Potassium ion is over here and hydrogen ion is here. So regardless which type of solution it is, concentrated or diluted, in both cases the potassium ions will be discharged. They will be easily discharged, which means at cathode potassium ions will be present at cathode, irrespective of the type of the concentration, because potassium ion lies at a very far from hydrogen ions. So the ease of discharge of the potassium ion is very easy. My mistake. The ease of discharge of the hydrogen ions is very easy. It is at a very far position, so it will be easily reduced, whereas the potassium ion will easily oxidized. So at cathode hydrogen ions will be present, at cathode hydrogen ions will be reduced. So according to this statement, at cathode hydrogen ions will be produced. And now for the anode, we need to consider the negative ions. We are getting two ions at anode. At anode we have two ions, the bromide ions and the hydroxide ions. Now for this purpose we have to look into the concentration level. Now looking at the table, we can see that there are two conditions provided here, the concentrated and the diluted. The concentrated KBr indicates that bromine will be discharged at the anode, but if we were using diluted form, then oxygen was produced at the anode. Why is it so? Because at concentrated point the amount of the bromide is more as compared to the hydroxide ion of the water. Because if hydroxide ion was discharged, it would have produced O2, which is not in our case. Instead, it is the concentrated form of the KBr. The concentrated form of the KBr is giving a more amount of the bromide ions, and because of that bromine is produced. And from this table you can easily see that hydrogen gas is being produced both in the diluted as well as in the concentrated form of the KBr. So The right option becomes the bromine at anode because of its high concentration. So the right option becomes A. Now the next question, question number 11, it states hydrogen, oxygen fuel cells and gasoline are used to power cars. Are each used. Which statement describes an advantage of using hydrogen oxygen fuel cells in cars in comparison with gasoline engines? So here in this question we need to find the advantage of the using hydrogen oxygen fuel cells. So for this purpose we should have some knowledge of this topic, specifically speaking hydrogen oxygen fuel cell. So we can have this idea from this table. You can take the screenshot if you want, so that you can compare all these points with the points given in the question. So coming back to the question, it says that the hydrogen is a non-renewable source. Hydrogen is a non-renewable source. It is not correct. Hydrogen is considered as a renewable source in case of the hydrogen oxygen fuel cells, because the use of hydrogen oxygen fuel cell is basically specified for the renewable source of the energy. For this purpose we do not say that hydrogen is a non-renewable source. We can see this in the first point, that the advantages of the hydrogen as a fuel is that it is renewable if produced using the solar or wind energy. So it is considered in the advantage. So that's why we will say that A is not a correct answer. Then the next point is hydrogen is produced during the fractional distillation of petroleum. So if it is produced through the fractional distillation of petroleum, then according to this point we will say that this is not considered as an advantage, because if it is produced through the fossil fuel which comes under petroleum, then it will be considered as a disadvantage, not an advantage. So that is incorrect. The B part is incorrect. Then the D part, hydrogen oxygen fuel cells need electricity to work. So we know that the purpose of using hydrogen oxygen fuel cell is to produce electricity, not to use electricity. The purpose is to produce electricity. So D is incorrect. And then C is hydrogen oxygen fuel cell do not release carbon dioxide. So yes, that's the correct answer, because there is zero emission of the carbon dioxide using this cell. So that's why the correct option becomes C. So I will select this option as the correct answer. Now the next question, question number 12. Plant cells use energy from sunlight for photosynthesis. Which row describes and explains the energy change that occurs? Okay, so as you must have read in your literature that for the photosynthesis we consider that sunlight is absorbed by the plants. Sunlight is absorbed by the plants. So since the energy is being absorbed, the type of the energy change will definitely be considered as an endothermic, because its heat energy is being absorbed or taken. But then what is the explanation for this energy change? For endothermic we will consider that delta H has a value of positive. The endothermic is shown by positive delta H. But what is the explanation? For the explanation we need to look into the theory. So I will show you my notes of all levels. In my notes you can see that this is the formula to find the enthalpy or energy change. The formula is energy taken in when bonds are broken minus energy given out when bonds are made. To make it easier for you, I will simply write it as that enthalpy change is equivalent to energy which is taken minus energy which is released or give out, or in the words according to the statement in the question, I will say it is absorbed minus released. So it will be more convenient for you to find the answer. The value should be positive. Delta H value should be positive. In this case, to have a positive value, it means that we should either have the value of absorption to be higher, or in other words, the value of the release should be smaller. So we can see this in the statement that less energy is released making bonds than is absorbed to break bonds. So this option becomes correct. The less energy is released, so less energy, when there will be less value of the released energy and more value of the absorbed energy to break bonds, then we will have an endothermic situation. So both, according to explanation, both options A and C are correct. But since the first row has both the options correct, so our right answer is A. Now our next question, number 13. Two different experiments are done to find the enthalpy change, delta H, of each reaction. The temperature of each reaction mixture is measured at the beginning of the reaction and after 3 minutes. So we have these pictures of the experiment number 1 and 2. Then it says which row gives the correct sign of the value of delta H for each reaction, for each experiment, and identifies if the reaction is as endothermic or exothermic. Okay, so for this purpose we have to take the correct reading from these given pictures of the thermometer. Only then we'll be able to explain experiment number 1 and 2. So it says that the left diagram indicates the initial temperature and the right diagram indicates the temperature after 3 minutes. So I will check. I can clearly see that this is coming at 26, value of 26, which means it is 26 degrees centigrade, and on this right picture it lies at 17 degrees centigrade. So it is 17 degrees centigrade. Now coming over here, this value is somewhere at 24.4 or 3. Let's suppose I say it's 24.3 degrees centigrade, and then this diagram indicates that the value is somewhere at 39.9 degrees centigrade. So I have taken the readings from this experiment. Now I have to check which column is right. I can see that for experiment number 1, the value is decreasing. There is a decrease in the temperature. So the decrease in the temperature indicates that the experiment shall be endothermic reaction, and for which delta H value is positive. So from experiment 1, I will say it is an endothermic reaction and the value should be positive. Now for experiment number 2, the temperature has risen from 24.3 to 39.3, which means it is an exothermic reaction and delta H value will be negative. Now I have to check this from the column. For experiment number 2, it is an exothermic reaction and the value should be negative. Delta H value should be negative. So I can clearly see that the option C indicates all the ticks here. So right option is C.